Hello everyone, this is Avenkat. Now I would like to explain my task, that is offline customer support chatbot. The main aim of the task is to to secure the user's data without sending that data to internet. Store the data in the local machine only. It provides more security to the user data. This is the main goal of my task. I have implemented a fully private offline AI-powered chatbot using Python, Ollama, and Meta's LLM model 3.2 3B model. Now let me explain overview of my task. The project demonstrates a privacy first approach to AI for customer support. Instead of sending customer queries to the cloud, the chatbot runs entirely on local hardware using Ollama, an open source LLM server. I have implemented through prompt engineering strategies. First one is zero shot. That means we have given only query only, no not provide any examples in one shot. Give the model and role and one example. Analyze the both results and store the append the results in evaluate readme.md file. Readme.md file. Now I will explain overview of data flow. First load the query from the queries list and then insert the query into zero template.txt file. First test with zero prompt, zero shot prompt engineering strategy. After that, one shot prompt engineering strategy. We have to test both strategies, how model works on each strategy. After that, post the request to the server. Ollama is a open source server. It run on port 11434. It provides pre-built LLM models. I have used LLM 3B model. 3B means billions, 3 billions parameters. After that, it return back JSON response. Same two to step 2 to step 5. Repeat for one shot template.txt file and append the both scores to the results.md. Repeat repeat the above process for all 20 cores. This is the data flow. Now let me explain the architecture of my task. My task is divided into two main two tiers. First one is local machine. Second one is OLM server. Local machine means in that we have to take the query from the queries list and insert the query into zero shot template.txt or one shot template.txt. First do with this. After that, go to one shot template.txt. After send the prompt, it sends the prompt to the Ollama server. It already run on 11.11.11.434 port. It is an open source server. It provides the pre-built models. I have used LLM 3.2 3B model because it provides 2 GB and efficient for demo purpose. After that, it analyze and generate the response back and score and analyze the result manually or heuristic way. Analyze these three parameters: relation, coherent, and helpfulness. Now let me explain the features of task. This is the 100% offline. That means all inference runs on local hardware, no API keys, no cloud calls, no data leakage. LM 3.2 model. State of the art open weight model quantized for consumer hardware. It is best for efficient for hardware. I have implemented two prompting strategies and auto scoring, structured logging, pure Python, request and parameters, CCPA friendly. Customer data never leaves the premises. Project structure. This is the process chatbot, main script, queries, API calls, report.md, full analysis of my task, and setup.md, step-by-step environment guide, readme.md. This file it tells overview of my task. This is the zero shot prompt. This is the one shot prompt result.md. Auto-generated evaluation log by the chatbot.py. That results can be stored here. Report means full analysis, methodology, results, conclusion, totally. And now let me explain how to start and how to test. First, you need to install the Ollama in server in your laptop. Go to this link and install. Pull the LLM model from that. After that, follow the steps. Navigate to project folder and create an active virtual environment. After that, pip install required dependencies. Ensure Ollama server is running before doing this task. After that, test this URL in our Chrome browser. Then it shows Ollama is running. After that, we have to run the Python chatbot.py file. The script will process all 20 queries into two methods and write results to the result.md. After running successfully, we have to test the application by using this following command and full test by using the after a full test run terminal output like this expected terminal output like this model endpoint query done how many queries done result saved to all done. This is the expected output in console. Now let me explain what are the challenges I faced. Data privacy. Cloud providers better for raw performance but require sending data externally. It's somewhat data risk. Local models are private but constrained by hardware and model size. Inference speed on CPU. LLM model generate this response at 5 to 20 tokens on CPU only hardware. It requires hardware efficiency and hardware depends on hardware working process also. Hallucination risk. This model gives the result confidently whether it is wrong. Prompt sensitivity, dataset adoption effort. These are the challenges I faced during the implementation of this task. Future implements. I need to implement RAG integration, connect to live knowledge base for accurate ground responses purpose. GPU acceleration. My CPU is a little bit slow when compared to GPU. That's why I have to implement GPU acceleration in future implements. WebUI, I have to implement the WebUI fine tuning. Fine tune on realistic support conversation using LORA or QLORA. Automated evaluation, LLMS judge, WebUI, structured JS1 format. These are the future requirements I need to implement. That is the overview of my task. Sorry for that, I could not run on my laptop because of memory storage is not enough to run this task. That's why I cannot run in my own device. But I provide how to run everything in a readme.md file. Please carefully study the readme.md file and work on it. Thank you.